Welcome to a video where we will learn how to find where rational functions are increasing, decreasing, and the coordinates of any relative extrema using the free online graphing calculator website, Desmos. Let's get started. Throughout this video, we'll be referring to the function f of x is equal to 8x squared divided by the quantity x minus 6 squared times x plus 6. Let's start by finding the horizontal and vertical asymptotes for this function. Let's take a minute to review how to find the horizontal asymptotes for rational functions. We want to compare the degree of the numerator and the denominator. If the degree of the numerator is higher than the denominator, there's no horizontal asymptote. If the degree of the numerator and the denominator are equal, then the horizontal asymptote is the ratio of the leading coefficients. If the degree of the denominator is higher than the numerator, then the horizontal asymptote is the line y equals 0. So looking at our function, if we want to find the horizontal asymptote, we first need to look at the degree of the numerator and the denominator. The degree of the numerator is 2, and the degree of the denominator is 3, because that first factor x minus 6 is squared plus the x from the x plus 6 factor. So since the degree of the numerator is smaller than the degree of the denominator, there is a horizontal asymptote at y equals 0. Now let's find the vertical asymptote for this function. Before we do this, let's review how to find the vertical asymptotes. In this case, we need to look for zeros from the denominator. The line x equals a is a vertical asymptote of the graph of the function if x equals a is a zero of the denominator and does not come from a common factor of the numerator. Zeros of the denominator that are also zeros of the numerator result in a hole in the graph. So to find a vertical asymptote, you need to first find the zeros for both the numerator and the denominator. Zeros for just the denominator are the vertical asymptotes. Let's look back at our function and find the zeros of the numerator and denominator and then compare them. For the numerator, there is a 0 at x equals 0. For the denominator, there are zeros at 6 and negative 6. So since those zeros of the denominator, 6 and negative 6, are not in common with the zeros of the numerator, we have vertical asymptotes at x equals 6 and x equals negative 6. There are no holes in this graph since there are no zeros in common to both the numerator and the denominator. Now let's determine where this function is increasing and decreasing and the coordinates of any relative extrema. First, let's remind ourselves, what does it mean to be increasing and decreasing on an interval? A function is increasing on an interval from a to b if the function values increase as the inputs increase. So if you're reading a graph from left to right, the function is increasing if the function is going up from left to right. A function is decreasing over an interval a to b if the function values decrease as the inputs increase. So once again, if you're reading the graph from left to right, if the function is going down, then it is considered a decreasing function. Relative extrema occur where the function changes from increasing to decreasing or decreasing to increasing. You'll have a relative maximum when the function changes from increasing to decreasing. Typically, relative maximums lie at the top of a hill or a mountain. A relative minimum is where the function changes from decreasing to increasing. Visually, relative minimums will always lie at the bottom of a valley. Now let's take our function and go over to Desmos to determine where our function is increasing and decreasing. From the website desmos.com, click on the button where it says Graphing Calculator to open the Graphing Calculator website. Or from the Math Tools menu, you can click on the Graphing Calculator. When the Graphing Calculator opens, go over to the upper left-hand side and enter your function. I've already entered the function for us on this graph. Here's our function for f of x. But we found that this function has a horizontal asymptote and 2 vertical asymptotes. So I'm actually going to add these to the graph just so we can see them. So here's our horizontal asymptote at y equals 0, and our vertical asymptotes at x equals -6 and x equals 6. If you're wondering how I changed the color or I changed the type of line from a solid to a dashed line, you can just press and hold on the graphing settings button on the very left, and you can select the color and you can select the line to be a dashed line. So I usually like asymptotes to be a dashed line, just so I don't confuse them with the actual function. I've put a link to this graph in the description of this video if you'd like to open a copy for yourself. Now let's determine the intervals for where this function is increasing and decreasing. We always want to read the graph from left to right. So I'll start from left to right. We're starting at -infinity, and we can see that the graph is decreasing until the vertical asymptote at -6. So our first interval, we're decreasing from -infinity to -6. And then after the vertical asymptote, we continue decreasing from -6 to 0. At 0, we turn the corner and we change to increasing. So we're increasing from 0 to the next vertical asymptote at 6. And then after the vertical asymptote at 6, we once again decrease until infinity. So we're decreasing on the intervals from -infinity to -6, from -6 to 0. We're increasing from 0 to 6 and decreasing from 6 to infinity. Now let's find the coordinates of a relative extrema. For relative extrema, we're looking from where the graph changes from increasing to decreasing or decreasing to increasing. Really, you want to look for your mountaintops and valleys. Since we have a valley at this point, 0, 0, we change from decreasing to increasing. This is a relative minimum at 0, 0. There are no other relative extrema on this graph. You might be wondering, well, the graph changes from increasing to decreasing at that vertical asymptote at x equals 6. Is that a relative maximum? And the answer is no. You cannot have a relative maximum or minimum at a vertical asymptote. Relative maximums and minimums have to be contained in the domain for the function. So although it changes from increasing to decreasing, since that point x equals 6 is not in the domain, we are not at the top of a mountaintop, it is not a relative maximum. So that's why I always say relative maximums will occur at the top of a mountain, relative minimums will occur at the bottom of a valley. Let's go back and summarize what we found from the graph. We found that this function was increasing on the interval from 0 to 6 and decreasing from -infinity to -6, and the interval from -6 to 0, and the interval from 6 to infinity. We had one relative minimum at the point 0, 0. Let's finish this problem by finding the domain and range. For rational functions, we find the domain by starting with all real numbers and eliminating the points where the denominator is 0. So for this problem, our domain would be all real numbers except those 2 vertical asymptotes where x was 6 and -6. Writing this in interval notation, we would say the domain is from -infinity to -6, from -6 to 6, and from 6 to infinity. We have to write 3 intervals here because we use the round parentheses to exclude the points 6 and -6 from the domain. The range for this function was from -infinity to infinity. Even though we had a horizontal asymptote at y equals 0, y equals 0 was in the range because the point 0, 0 was actually our relative minimum. In general, it's okay to cross a horizontal asymptote, but you can never cross a vertical asymptote. So vertical asymptotes will never be in the domain, but it is possible for horizontal asymptote to be in the range. That's it for this video. Thanks for watching.